Okay, welcome back. This is part two. So we are going to look at some code today. Some functional code. But I think if I recall last time, go ahead and get this out of the way. If I recall last time, what we did was we looked at a couple of repos, just open source repos on GitHub, some JavaScript ones, recent ones, and we just tried to find some repos that we thought could benefit from introducing functional concepts, or repos that already tried to introduce functional concepts but didn't quite get there. So we looked at a couple different repos, but I think the one I remember is, let's see if I can find it. I think it was an API wrapper around Axios, and it was called API Sauce, I believe. It might have been all one word. Yeah, I believe it was this one. Yeah, okay, I remember this. Kind of reminded me of message passing a little bit, but okay. So yeah, this is just a wrapper around Axios. We looked at some of the issues, but we wanted to dive into the code today. So let's look at, I believe there was a top level file somewhere. API, maybe this is it. API sauce. Um, this was just the definitions. Yeah. So we had, these are the definitions, but this isn't the file that I was thinking of. Oh, this is the definition file. My bad. My bad. My bad. It's early, and I'm still working on my AG1. Library, maybe? Yeah, let's look at that. Okay, yeah, I think this is it. There's a two number function that we looked at, and then is within. Yeah, okay. So we're just gonna actually take a closer look at this and see what we can introduce that's either functional or more functional. And I think last time I just kind of said that, yeah, this is fine. I would actually use, if I'm going to do this functionally, I would use functional libraries to do this kind of thing. So to do this instance of check, maybe to definitely do this type of where you're just trying to check the type to see if there's something there, I would use libraries. And so that's a good segue to the libraries. So the first library that I always gravitate to when writing functional JavaScript is Ramda. So this is Ramda.js. These are the docs. This is kind of where I live, and I'm always trying to find functions that are kind of done for me, like higher order functions that are done for me that I can just bring in, right? And if things kind of get to a point to where I'm doing a lot of composition, or I want to actually take, I want to do more than just compose functions, and I want to do like actual functional control flow using functors and using monads and those types of things, then I'll use typically Ian's library. Oh, EvilSoft, Crocs, I believe. Crocs Yeah, okay, I have it here. Still. Yeah, so I will use this library um, for, and he does a fantastic job. Ian and the rest of the folks that help him uh, do a fantastic job of compatibility with different versions of JavaScript. As you can see, there's common JS and modules versions of this, but yeah, there's lots of great functions. There's monoids in here, just very similar to Ramda, but just like takes it a little bit, takes it one step further with the functors. So there's like an async and some other stuff. Anyway, I'm not going to get too far into this, but those are if it gets to a point to where I want, like I said, that control flow, that I want to do more than just composing functions, I might pull out Crocs. But for the most part, and I think specifically for this, all we'll need is Ramda. So let's get back over here. Oh, one other thing that I did want to mention is rather than using like a full-fledged editor like Visual Studio Code or Cursor or something like that, which we might use, there's a couple different ways that we could pull this code down and start to work on it. We could use like I said, we could just pull the code down and use an editor and just kind of get in there, or we can use a REPL. And this is kind of what I like to do. So the REPL I like to use is runJS. It's here. Okay. So this is what we'll be using today. Is this REPL? You write some JavaScript code. It evaluates on the right-hand side. Since my face is down here in the corner, I'm actually going to have a different layout. Mine will be like kind of going across the bottom here, and then the code will be on top. But yeah, so runJS, if you don't know about that, and you write JavaScript, get it. It's worth it. Okay, so let's fire up runJS. All right, cool. So we have runJS here. So now, instead of just pulling this code down and pulling it up in an editor, I'm just going to move it over into runJS, and we're just going to work with it there. So like I said, I would use high-level functions for this. So like Ramda, I believe, has is it's been a while. Forgive me. It's been a while. It's been almost a year since I've been in JavaScript land, but I know that Ramda has. Are they objects? I know that Ramda has. So like there's keys where you check object.keys. There's map keys, object of. Creates an object containing, not quite. Anyway, it's in here somewhere. I don't remember what it is. But anyway, yeah. So that's kind of what I would look for the Ramda equivalent for this and use that. But like I said, this function is two numbers fine. I think is within is great. We established that last time because we're just taking the inputs of the function, min, max, and value, and we're just using it right here in the body. And the great thing about this is that it's an expression, right? And this is, as functional programmers, we want our code to be as intentional and as clear as possible. This demonstrates that quite nicely. And this is sort of what we want to strive for in kind of all of our functions, if we can, right? Is this clarity and this like simplicity with not a lot of noise around going on. Is promise down here exactly the same thing, right? it's an expression. So great. I love to see this. And then we got down here, and then yeah, we determined that these were just constants, right? Arrays. And then, was it this function? Yeah, it was this function. So this function, yes, this function, get problem from error, has a lot of if statements in here, right? Which is fine. This is normal JavaScript code. This is you're going to see this everywhere, and it's fine. It works. It's great. But you just want to be careful, right? Because if this gets too long, right, this could easily grow and grow and grow and grow and grow. And at what point do you actually want to address, you know, all these ifs, all these inline ifs, right? They're fine, but at what point do you want to address it? That's the question. As someone who's been writing code for a while, these are the things you start to think about, and so that's what's on my mind right now. Specifically, how we're checking for the code here. So the error is coming in. We're dotting into the message to get access to the message to check if it's a network error. Okay. Which is an Axios thing. And that's fine. And then we're dotting into code, and then we're dotting into response. And then we're dotting into response.status. And then we're dotting into code here, here, and here. So we're using a lot of dot notation to access properties on an object. And in JavaScript, we could pattern match that, right? And we could just pattern match those properties out, pull them out, and the code could be a little bit cleaner. But let's start pulling some of this out. So first thing I want to do is I'm just grab this function, because this is a function that we want to kind of work with a little bit. So I'll pull this out, pull this in here. Good. So let's see. Gonna need Axios. So let's see if I can find that import up here. Yeah, okay, cool. Okay. And then I'm gonna need Ramda at some point. I don't know what I'm gonna pull in yet, but I'm just gonna stub this out. And okay, so we've got Axios. We've got this function here, and right. So let's try to address the dot thing. The other thing that we want to address in this video is just this, like, you see how we're checking, so we got to bring these in. So let's go grab them. Timeout errors, Node.js, and status. We want these. Okay. Here. What else? We need this function, get problem from status, and then we also need timeout error and connection error. Unknown error as well. Timeout, okay, here, timeout error, connection error, network error, unknown error. I mean, I guess we could just bring all of these in. Let's just bring in, yeah, let's just bring these in. They are above, so we'll do this, and then we'll just take these exports out. Oop. All right, so we've got our errors, we've got our arrays, cool. And then we have our function get problem status, so we need to bring that in. That's here, looks like. Uh-huh. And, oh, okay, well, maybe if we have time, we'll get to that, but, all right, so get this uses, and we don't need this. This we need, but we don't really need to look at it, so let's collapse that down so that we can make space for what we do want to look at, which is get problem from error. So we want to take a look closer at this function. Okay, before I get into it, let me bump this up a bit and make some more space and actually just create an error that has these properties on it. So I think what I need is an object. That object needs to have a message. The message is going to be some message. We'll put it in a second. We need to have a code. And the code is going to be something. We'll put that in a second. And then I think, yeah, response. That's an object that has a status on it. Is that right? Error has code. Error has message. Error has response. And response.status. Okay, I think we're good there. All right. So we have this. So now we can just try to run it. Problem from error, and we give it error. Like this. Unknown error is what it returns. Okay, cool. Yeah, unknown error. Okay, cool. So it's giving us unknown error, which means it's trying to check a message. It's not the network error. It's just checking all these ifs, falling through, and getting to unknown error, which, based on what we're giving it, yes, that's true. So now I need to give it a message. Let's just give it network error. See if that gives us what we want. It does. Okay, cool. Let's not give it a message. And let's give it a code. And the code, well, if there's no, well, let's see. Okay, so the code is being checked in status error codes. It's being checked in timeout error codes. And it's being checked in Node.js connection error codes. Let's, that involves, running these two involve this function. So I want to just pause on that for a second and then come down here to timeout error and connection error. So timeout error codes, let's see, timeout error, okay, there's only one. So if I give it this timeout error, now I get a timeout error. Okay, cool. If I give it a connection error, Node.js connection error, like this one. Okay, cool, I'm getting the connection error, okay. So that's telling me that these two down here are working just fine. So now let me try this one, this status one, right? Try the status one. That means I would need no code at all first. Unknown error. So problem from status. Let's take a quick peek. Okay, it is to returning unknown error because, yeah, there's no status. So it's returning unknown error. Okay, so it is calling this function based on this conditional, which is basically all I was trying to check. And then status, okay, so we'll get to that. A status error code, let me just try to check that and see. So now I want to give it a code, but I want to give it this code, unknown error. Okay, cool. So that tells me that it skipped over this one, or there actually is a code. So it skipped over this one. It went here and then went in here. And I guess instead of falling down here. So in order to understand where this is really coming from, let's just do this real quick and say that, just so we know that it's coming from this function and not the function we're in. And you can see as I'm typing it out, it's in there, right? So that's where this error is coming from based on me giving it this code. Cool. All right, so these conditionals are now working and everything's good to go. The right things are happening. The right timeout errors are getting returned out of this function. Okay, cool. So now we just want to simply address these the things that I called out. So the first thing was the pattern matching, right? So I'm sorry, JavaScript. So I think it was it where you, when I say pattern matching, all I mean is like this, where we're doing message and we're doing code and we're getting it from error, right? And I think that now that I typed that out, it's not pattern matching, it's destructuring, I think. Destructuring is the JavaScript terminology, but I just say pattern matching because this is very analogous to languages like OCaml or F sharp or even Erlang. So, an Elixir. But that's what I mean when I say pattern matching. So instead of having to dot into this, we could just bring those out, message code, and message code, and then I want response, and then I want status. What is the syntax for nested destructuring? So I want to go down a level because I've got this response status thing here. And I cannot, is it, I don't remember, forgive me. That's not it. Response status. Ooh, from the response, we want the status. Off the error. Oh, maybe that is it. So we could do something like this. We're getting unknown error. So then we would just need to be able, then we could just like kind of clean up this dotting syntax right here, right? We could just say, well, if there's no code, if there's, I don't know if that's going to work. I don't know if response, well, if error is on the, if response is on the error, I should be able to, okay, that's still working. So, yeah. So then I should be able to just say response and then status here. Still working. Okay. And then I could clean up code, status, code, code. All right. Let me try a different error. Let me try a Node.js connection error just to make sure that's still working. It's still working. Okay, cool. So this is kind of one thing we could do to kind of clean this up. We could clean this up even further, right? Because error, there's duplication here. And again, you want to, as functional programmers, we're thinking about the data more than anything else. We're thinking about the data, and functions themselves are just data. And so when you have this sort of hyper focus on the data, you tend to arrive at more succinct code like this, right? And you start to develop a tolerance, a low tolerance for code duplication. Because at the end of the day, you're just trying to get things, tidy things up and get them into functions and be as expressive as you can. And having that mindset drives this kind of thought process, which results in this type of code. So I could clean this up even further, and there may be some arguments about this, but I could clean this up even further because this is just referential transparency, right? And I gotta add the parens because this is an argument. So I could clean this up even further and say, okay, an error is coming in here, and it's gonna give me a message, a code, a response, and a status off that response. And then I could just simply use that here, right? So this is just another way of kind of cleaning things up. We'll leave it there for now. It's not hurting anything. I just want to kind of illustrate the point. But the next thing I want to tackle is these if statements right here. So really all of these, I guess. So what I'm seeing is we have a code. The code comes in. We're checking to see if that code is in status error codes. We're checking to see if that code is in timeout error codes, right? We're checking to basically see if the code is here, 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 because we're trying to determine what kind of error is this. Is it a timeout error? Is it a connection error? What is this? What do we have, right? So I'm thinking about generalizing this because this is I'm seeing duplication. I'm seeing it's not, like I said, there's nothing wrong with this code. It's fine, it's working. But if I'm being a little bit meticulous about it or trying to think ahead as an engineer who often has to come into brownfield projects like this and maintain them or, you know, enhance them in some way, I'm going to look at this and see that this could be a potential area that's going to grow. Because if I take a step back and think about it for a second, this is, Apisauce is a wrapper around Axios. And the goal, let's just remind ourselves real quick of the goal here. The goal here is to responses have a problem property to help guide exception flow. All responses follow the same flow, success and failure alike. So to me, it kind of, I don't know anything about this library, but to me it seems like you're trying to capture the problem flow, right? Error flow. Talking to APIs doesn't have to be awkward. So you're trying to capture the flow of successes and failures. And so in this particular case, let's come back. In this particular case, we're trying to capture error flow, right? And we're trying to do that in a way that not only differentiates API sauce from Axios, but gives the caller, gives the user as much information and context as possible, right? That's the goal. And so when I'm thinking about this, this could easily grow into more types of codes in the future, right? Either these are going to grow, well, maybe not connection errors, those might just be, connections just might be connections, but statuses could grow. Um, there could just be other types of codes that I don't know, they want to introduce. And so just seeing this as a potentially growing pattern, we want to kind of address that. So when I see when I see multiple if statements like this in a row, I immediately think of a function that captures that same idea, right? So a normal JavaScript developer might say, well, we could put in a switch here and just switch on code. And that's fine, you could do that. But a switch it's a construct that is not necessarily composable, and the whole idea behind functional programming is we want to strive for composability, even if we're not composing it at all, right? We still want to strive for that because it gets us into that, it keeps us in that mindset, but then it also may actually give us the ability to compose it later that we don't see right now in front of us, right? So I'm thinking, let me go to Ramda. What is the name of that function? It's not going to be on the object. It's going to be on maybe list. And list is basically arrays. That's how Ramda treats arrays. They just call them lists because under the hood they treat it like functional lists. I don't remember the name of it. But it is conditional. Is it cont? Ah, yes. Oh, it's logic. Okay, yeah, because predicates. Okay. Um, yeah. So this is kind of what I mean. So, uh, let's bring in cond because I think this is going to be more like what I mean. Where should I put this? Let's collapse this back down. We'll keep error there. Okay, so let's break this down a little bit. So line 43 and 44, code, we're checking to see if there's actually a code that exists, and then we're running this function. We're also checking to see if code exists in status error codes, and then we're running the same function. And then inside here, we're basically doing a check to see, like, if there's a status, if there's a status, we're going to actually pass in the status. Otherwise, we're going to pass in null. Okay, again, we don't want to use nulls. We want to use like an option type or like we want to capture the essence of like a null, but not null in the null sense. And an option type or a maybe type or an algebraic type that gives you a value or not a value is kind of how we want to capture that. But that's a little bit too advanced right now for what we're working on right now. So we'll just leave it. Get problem from status. We're calling that with status basically. And then on line 45 and 46, we have the same kind of pattern where we're checking if the code is in here, then it's a timeout. If the code is in Node.js connection errors, it's a connection error. I think those are two different things. But before we get to that, let's bring in cond. So we brought in cond up here, right? So let's just try to map this same code out as a cond. So I think that would be helpful here. We're going to have to give this a name. I don't know what we could call this, because basically we're doing status and we're doing normal errors. So I'll just say to error, because we're checking the code and kind of returning back an error. But what kind of error is this, right? Well, it's an error that's defined here. So it's not an Axios error. It's an Apisauce error, right? So let's do toSauce error, whatever. And then toSauce error is actually going to be this cond, right? We don't like parentheses, or sorry, we don't like semicolons. So, okay. So the way this works is very similar to what we have down here. We have a list of lists. Each list is a conditional and a function. So if whatever you pass, so con is now waiting for its last argument, which is gonna be ran against this conditional, and this conditional. So it's expecting an integer in this particular case. If the integer is equal to 0, then it's gonna run this always function, which would write this out to the console. If the integer is 100, it's gonna write this one, and any other integer that it gets, it's gonna just write this out. Okay, and so we want to capture that in this case. Now, we have this get problem status function that's getting called for these, so I think we should treat status differently from timeout and Node.js connection errors. I think they should be treated differently because they're implemented differently, right? Here you're just checking if the code is in timeout error codes, you just return the timeout error that I've defined. If this code is in Node.js connection error codes, then just return the connection error that I've defined. I see that becoming more of a longer pattern than these up here, where you're just checking to see if it's a status, then I want to run this function and produce an error code that is a status specific error code. If it's not a code at all, if there's no code at all, we still want to go try and get that status, if there's a status. So I think those are different. So I think they should be separated out. Let's collapse this for a second, give ourselves some space, and let's create a predicate that captures this, and so includes. I know Ramda has an includes. It might be logic. Is it logic? It might be list. Maybe it's list. Yeah. Includes. Yeah, so it's the data last, so the list last, and then whatever we're looking for in that list. So that's includes. So let's bring that in. A, B, C, D, E, F, G, I, includes. Okay. And then we're checking, well, timeout error, connection error. These are sauce error codes, not Axios error codes, right? Let's just do is sauce error. So is sauce error is going to check the code and the actual code. So we need to pass them both in. So the code needs to be last if we want, we'll see why in a second, because we want that function right here, just like equals is waiting for an integer, we want a function that's waiting for the code, right? So Apisauce error needs to take the error codes, whatever they happen to be, and the code. And this is, okay, and then includes, just give me a second, includes, we want to check to see if the code is included in the error codes. And that's really all we want to do. So now we can replace this guy with is sauce error, and we want to pre-fill the first argument, error codes, with timeout error codes, right? Now, his sauce error is actually going to wait for that code. When it gets that code, it'll check it to see if it's in there. If it's in there, then it'll need to run whatever function we put over here. Right? So what are we putting? Well, we just want to return timeout error in this case. So we could either do this and return timeout error. Okay? Like, well, yeah. Return the timeout error, because it's just going to return it. Or, which is fine. I don't know, this might work. No, R is not, okay. I don't know. I don't know if this would work. This is how I would normally write it, but I don't know if that's going to work. So I'm just going to just use this empty. I'm just going to use this for now. There's a name for it. I can't remember the name for it. Yeah, I can't remember the name. And then we want to also do is sauce error on this other one. Node.js connection error codes, right? So we want that. And then the same thing there. And this is kind of how the, oh, not that. This is how I would see something like this growing in the future. It makes more sense to grow it this way because hang on, let me bring in, okay, so truth is basically this guy right here. Return unknown error. So I need to bring in A, B, C, D, E, I, J, L, M, N, O, P, Q, R, S, T. I need to bring in T. I need to bring in truth because this is basically your catch-all. And yeah, we don't need that, just this and unknown error, right? Yeah. Okay. All right, so to sauce error is waiting for the code. If the code is in timeout, then we're going to return timeout. If it's in Node.js connection errors, we're going to return a connection error. Otherwise, it's an unknown error. And that's basically capturing these 3 lines right here. So now we want to look at the status. And again, that's if it's not a code, right? Or if it's in status error codes. There's a couple ways we could do this. We could use or from Ramda, LMNO, HIJK, LMNOP. We could try or. And we could try, so this is not. We could try not, HIJKLMN, not, and we could just try to create another predicate that is sauce status error, maybe? I don't know. The sauce status error needs to take the codes and needs to take the actual code. Might need to take, no, it's just checking. So let's make it status error codes, I don't know. And then a code, and then so we could say or, because effectively that this is equal to this, okay? It's just in a function form instead of a more literal form like this. So we could try, again, we're just exploring here. We could try or and say, well, if there's not a code, right? Or if includes code status error codes, and not that one, but the one we're passing in. I mean, we could pass it straight in. It's really a preference here. We could pass it straight in and just use it like this. Or since they are literally constants and we know they're not going to change, we could close over, this function could close over these values like this, and we could just use them inside, and it would still be safe. So it's really style choice there. So we could do that. We could do something like that, or we could do. Let's just look and see, because it's a lot of nested like functions. We could just do not code or includes the code and the codes of the status, what we pass in, or we'll just use status error codes. Let's just make it really simple for just demonstration purposes. So if status error code is passing in the code, and if it's not a code, so if there's no code, or let me double check this. Yeah. So if there's no code at all, or if the code is included in status error codes, then it's true, and we want to run the get problems from status function. It's as simple as that. So we're going to leave toSauce error like this, and we're just going to create toSauce status error. Might be a little long in the name, but we just want to treat it a little bit differently. So the idea here is to run this predicate, is to see if it's a sauce status error. Right? So now if we begin to just kind of, well, we should be able to comment that out, and just return toSauce error, giving it giving it the code, because we pattern matched that off, or we destructured that, sorry. Okay. So that takes care of that. That's going to give us back either an unknown error or the correct one. And then if there's no code, so we want to, we could actually leave this as an if statement and say if this is a sauce status error, then return get problem from status. Okay. Yep. And we can make sure that, like, in terms of all the error checking, like the status to see if it's null and passing a null, whatever, like if it's null, it's going to be passed in. If it's an actual status, it's going to be passed in. So, I mean, regardless, this function is getting called with either status or null. And so, yeah, so we can actually just take this out now safely and reduce that down to just these 2 lines. And this should work. We can put this right here, and we can bump this back in, and we could safely remove this, right? And this is a much better solution. So, like, let me just put in a Node.js connection error so we can see if that's working. I need it in here. Oh, it is in here. And we're getting unknown error. So why are we getting unknown error? Let's see. Well, let's take this out for 1 second. Okay, so we are getting a connection error. If is, so toSauce error is working. That code is coming in. It's determining that it's a Node.js connection error. So this part is working. It's the fact that we put the status here, and now, okay, so it's not just picking up the code. We actually have to give it the code. There. So now it's determining that it's not a sauce status error code. It's actually a connection error code. All right, cool. And, you know, the function is out here, get problem from status, and we're just closing over it in this way by just using it directly. It would be more functional to pass it in here along with the error, but it's already getting a little long. But I just kind of want to show, like, this. I think this is a little bit more functional. We have our predicates, which are just functions that return a Boolean to determine if it's a sauce error, which this can now safely grow, and it makes more logical sense for it to grow in this way. And then there's the sauce status error, which is basically looking at the status to determine, if it's going to be a status or not, right? So if we try to give it a status error now, unknown error. My bad. We need a status. So this should be status here. And then let's take off the code because that's going to give us there. So now into is not defined, I believe. Yeah, so this function is getting ran. It's calling this function, which we don't have. It's actually over here in the, yeah, it's actually here. So, but I'm not going to bring it over. you get the idea, right? It's calling the function. We're just going to have blind faith that that function is doing what it needs to do. We know it's not, but we know why it's not. And ultimately, this is kind of what I was getting at when I'm saying, when I'm kind of talking through and saying, okay, we need to address this. So that it's just having that mindset and being able to acknowledge that these things are happening and just try to address it when you can. Hopefully, it doesn't take too long. But I think the next thing that we'll tackle is this create function, because if I recall, yeah, see, we've got an instance here that's being set to null, and then we've got an if else that's setting it. And this is again very common normal JS code. You're going to see this everywhere, but it's not functional, right? And we want to make this functional. So one of the things that we could do is over here in the Ramda, we could, I know there's an if else, right? So we could use an if else function, which is composable. Again, we're trying to strive towards composability here. If else just runs that conditional first, and then if it's true, it will run the true function. If it's false, it'll run the false function, right? So this just could be captured in a true function. This could be captured in a false function. And then you got your if else there. And then your monitors, yeah. Again, on the outside, we're pushing on the inside. This should be done more functionally. Here we're trying to be functional by pushing into these arrays, but there's a better way to do that. We'll look at that in the next video. And we'll look at these object keys. Like I mentioned before, like I mentioned before over here in Ramda, Ramda has functions, object functions to handle that. So you just give it an object and it returns a list containing the names of all the properties of the supplied object, right? So, so you can just use keys here, and then instead of for eaching through there, and then returning the instance. So we're going to have to look at this because I think this is more of an OO thing to see how this instance is getting used. We might need the editor cursor, but, and then we've got these loops here. So yeah, there's a lot to cover, but this video is already getting kind of long. So I'm going to stop it. I think I'm going to stop it here. Yeah. And I'm going to, just because I don't like looking at that reference thing, but yeah, so this is just real quick. Like maybe it wasn't that quick, but hopefully you get the idea about how to be functional. We actually didn't end up using or not, so but hopefully you get the idea. We brought in a few functional functions from Ramda, and we were able to kind of not have to really write a bunch of unit tests to verify things were working, because that's the beauty and the joy of the REPL. We wrote a couple of predicate functions and introduced a conditional function, or conD, however you want to pronounce that, and became a little bit more intentional about the error and how we're treating the error. Is sauce status error, or is this an actual sauce error? If it's not a sauce status error, then it's likely a sauce error of some kind. And that's all we're really trying to capture there. Yes, we could easily address these and make these a little bit better, but you know, this is hard coded. So like, yeah, we could definitely change that. But the idea is that we're identifying where that duplication was kind of creeping in a little bit and addressing it. So I'm going to leave that there, and I will see you in the next video. The next video, we're gonna go a little bit deeper into, we're gonna get into this create function, I think, and we're gonna refactor this and show how this could be a little bit more functional. right? Yeah. So I will see you in the next one.